Hello friends, today we are going to see the trick to solve clipper based sums under the topic wave shaping circuit, and let me tell you, this is the second video under wave shaping circuit. In the first video we have seen the trick for transfer characteristics. Now we are seeing the trick to solve clipper based sums. So let's jump directly to the sum and there only we will see the trick. So the first sum is from EC 2015. Two silicon diodes with a forward voltage drop of 0.7 volt are used. The range of the input voltage Vi for which the output voltage Vo is equals to Vi is. The circuit is given here and the options are there. So first take a look how I solve this sum and then I will show you the trick. So the answer is from minus 1.7 to 2.7. So you can see this D option will be the correct option. Interesting, right? So let's see this trick into detail. So the trick says first you have to open the diodes and find out Vp and Vn such that you will get the condition for diodes to be on and off. Okay. Using that you have to derive the condition for input and from that you have to get your output. Okay, this is the trick similar to our first video but the application is slightly different. Okay, so let's see this trick into the action. So coming back to this sum, here we were having this circuit and the question was to find out the range for which Vo is equals to Vi. Okay, so the trick says first you have to find out the condition for which diode is getting on and off. Okay, so for D1 you can see if you open it you will get this is your Vp and this is your Vn. Okay, so you can say Vp is minus 1 volt and Vn is nothing but Vo, which is nothing but Vi, because you can see if we open both of these diodes there won't be any path for the current. Okay, so we can say this resistance will be nothing but short circuited. Okay, so at that time Vi is equals to Vo. Okay, so we will say Vn is nothing but Vo and Vo is nothing but Vi. Okay, so we get Vp is equals to minus 1 and Vn is equals to Vi. Okay, so if we check the condition for which this diode will be on or off, so for that you have to compare with 0.7 volt, right? So you will write like this: Vp minus Vn should be greater than 0.7, right? Vp, you know, it is minus 1, Vn is equals to Vi will be greater than equals to 0.7 volt. Okay, so we can say minus Vi is greater than equals to 1.7 volt. Okay, if we multiply minus sign with this equation we will get Vi less than minus 1.7 volt. Okay, so this is what I have written here. Okay, just for explaining I have written all this thing. If you get familiar with this trick you can write directly like this. Okay, for on the condition will be Vi less than minus 1.7 volt. Similarly for off it will be just opposite, Vi greater than minus 1.7 volt will make this diode off. Okay, now let's check for D2. D2 you can see Vp will be Vo nothing but Vi, right? This is what we have seen for D1 also, and Vn is nothing but 2 volt. Okay, if we compare with 0.7 we will get Vp minus Vn should be greater than 0.7 volt. Vp is equals to Vi, Vn is 2 volt greater than equals to 0.7 volt. Okay, so Vi must be greater than equals to 2.7 volt for diode D2 to be in on condition. Okay, so this is what I have written here. For diode D2 to be in on condition, Vi must be greater than 2.7 volt, and for off it will be just opposite, that is Vi less than 2.7 volt is equals to off. Okay, so now we know the condition for diode to be on and off. Okay, and the question is we have to find out the range for which output voltage is equals to input voltage. Okay, you can see for the condition for which these diodes are open, then only Vo will be equals to Vi. So that means the condition in which both of these diodes are off, at that condition only we will get Vo equals to Vi. Okay, so this off condition will give us the answer. Okay, so you can see Vi greater than minus 1.7 volt, this is what we get from here. Okay, and for off of D2 we get the condition is Vi should be greater than 2.7 volt. Okay, so this is the range for which we won't get any diode in on position, so we can say Vo will be equals to Vi. Okay, so the correct option will be this T. So you can see if you use this trick, you can solve this type of sum very easily in less than 30 seconds. Okay, let me tell you, after every sum we are going to increase the level of sum. Okay, so now this is the second sum with a level up 2 star. Okay, and the question is V on for diode equals to 0.7 volt, but it is ideal otherwise. If Vi is equals to 5 sine omega t volt, the minimum and maximum value of Vo are respectively. And the question is from EC 2014 and the circuit is here and the options are given below. Okay, so we will use the same trick. The trick says first we have to find out the condition for which the diode will be on and off. Okay, so for that we will open circuit this diode and find out Vp and Vn. Okay, so you can see this Vn of this diode is connected to 2 volts, so we will say it is 2 volt. Vp will be equals to Vo and Vo will be equals to Vi, because if you open this diode there won't be any current flowing from these two branches, so we can say this Vo node is nothing but equals to Vi node. Okay, so we get the Vp and Vn values. We can find out the condition very easily now. We are going to compare with 0.7 volt. Okay, so Vp minus Vn should be greater than 0.7 volt. Okay, Vp is here, Vn is 2 volt, should be greater than 0.7 volts, so Vi should be greater than 2.7 volt for diode to be on condition. Okay, so now this is the condition that we were required. So let's move to the question again. The question is asked about the minimum and maximum value of voltages. For minimum value it is lot more easier because we have to find out the condition in which this diode will be on. Okay, we know the condition where Vi is less than 2.7, that condition we will say diode will be off. Okay, so we will get as Vo is equals to Vi. So the minimum value will be minus 5, right? Because the minimum value of Vi is minus 5 here. Yes, you can see this is a sine wave. Okay, so you will get the maximum value as plus 5 and the minimum value as minus 5, right? And the minimum value of this input voltage is minus 5. Okay, so we can say the minimum value of output voltage will be also equals to minus 5. Okay, so we got the minimum value. Now we are required with maximum value only. Okay, so for maximum value you can see if we consider that Vi less than 2.7 volt, that time Vo will be equals to Vi. Okay, so at this condition we can get the maximum value up to Vo is equals to 2.7 volt, right? But we won't get much higher that. Okay, so now we have to check for the condition where this diode is also on and we have to find out what is the maximum output voltage it is providing. Okay, so for the condition Vi greater than 2.7, you can say this diode will be on and you will replace it by plus minus 0.7 volt. Okay, so now the circuit you get is this one. Okay, so this is your 1k resistant, 1k resistant, this is your 0.7 volt and plus minus 2 volt. Okay, so this is the circuit and the voltage at this node is Vo. Okay, this is Vi. Okay, so basically we have to find out the voltage across this branch to get the output voltage. Okay, so for that we must know the voltage across this resistor first to get the voltage across this branch, right? So for that we will first find out the current. Okay, so since we know this diode is forward biased, okay, so the current will always flow from anode to cathode. Okay, so the current will flow from like this. Okay, so if we apply the KVL we will get minus Vi plus 2ki. Okay, this 1k plus 1k 2ki plus 2.7 volt equals to 0. Okay, so we get I as Vi minus 2.7 upon 2k. Okay, so we can say it as Vi minus 2.7 upon 2 milliampere. So now we get the value of I, we can find out the value of Vo easily. Okay, so let's say this is plus minus Vo. Okay, if we apply KVL like this we will get minus Vo plus 1k I plus 2.7 volt. Okay, is equals to 0. Okay, so Vo will be 1k I, we know it is Vi minus 2.7 upon 2, it is in milliampere, so it will be cancelled with kilo ohm plus 2.7, right? Now since we want the maximum value of output voltage, so we will put the maximum value of input voltage here. Okay, so 5 minus 2.7, it is nothing but 2.3. 2.3 by 2, it will be 1.15, right? So 1.15 plus 2.7, okay, if we add up we will get 3.85 volt. Okay, so this is the maximum voltage and the minimum voltage is minus 5 volt. So from the option you can see this C option is satisfying this one. Minus 5 is the minimum and 3.85 is the maximum. So the correct option will be this C one. Now this is a 3-star sum, level up sum. Okay, so the sum is V in is equals to 10 sine omega t. Assuming diodes are ideal, the maximum and minimum values of output waveform V out of the circuit are respectively, and the sum is from EE 2003. The circuit is this and the options are given below. So here also we are going to use the same trick, and you can see the circuit is similar to the previous sum where we were having one resistor extra in this branch. Okay, so this is the add-on sum with this branch extra to it. Okay, so let's solve this sum with the same trick. So this is our D1, this is our D2. So for D1 the on condition will be, since the diode is ideal, so we can say Vp should be greater than 4 volt, right? I hope now you are understanding this thing when I am writing directly. Okay, so we get the condition Vp is should be greater than 4 volt for D1 to be on, right? And for D2 you can see Vp is minus 4 volt and Vn is nothing but Vo is equals to Vi. Okay, so here we are saying that Vo is equals to Vi because when we open both of this diode there won't be any closed path. Okay, so the current flowing through this circuit will be 0 ampere. So we can say this node and this node will be at the same potential, so Vo will be equals to Vi. Okay, so that's what I have written here. Vn is equals to Vo is equals to Vi. Okay, so for on condition Vp must be greater than Vn. Okay, Vp is minus 4 should be greater than Vn is nothing but Vi. Okay, so we can say Vi should be less than minus 4 for diode D2 to be on. Okay, so now let's use this input values to get the output voltage. Okay, so for first, when V in is greater than 4 volt, okay, so at that time diode D1 will be on and we can say VO will be 4 volt and this will be the maximum voltage. Why? Because if we consider for V in less than 4 volt, let's say it is greater than 0 volts, so at that time diode D1 will be off. Okay, so whatever the input voltage we will get at the output. Okay, so at maximum we can get 4 volt but not more than that. Okay, so the maximum voltage that we can get is VO is equals to 4 volt. So now let's check for V in less than minus 4 volt. Okay, which means that V in will be like minus 4.5 minus 4.8. so you can see this cathode is getting more negative potential as compared to anode. Okay, so we can say this diode will be on. Okay, so we can say for V in less than minus 4 volt, we can say this diode D2 will be on and we will have the circuit somewhat like this. This is your V in and this is your 10k. This will be short circuited, this will be minus 4 volt and this is your 10k. Okay, so to get the output voltage, that this one we must know the voltage across this resistor. Okay, and as per the previous sum we know first we have to find out the current and then from that current we have to find out the voltage that will give us the exact output voltage. Okay, so let's find out the input current first. Now take care of this, that current will be always from anode to cathode. Okay, so you can see anode is here, cathode is here, so the current will flow from here. Okay, as you know the diode is a unidirectional device which allows the current to flow from anode to cathode only. Okay, so we will say the current will flow like this. Okay, so if we apply the mesh like this we will get, this is your plus minus, so we will get plus V in plus 10k 10k 20k I plus 4 is equals to 0. Okay, so I we will get V in plus 4 upon 20k and this is in negative. Okay, so this is what I now we can use this guy to get VO. Okay, so this is our VO. If we apply KVL we will get minus VO minus 4 minus 10ki. Right, I have written minus here because we know the current is flowing like this but we are applying KVL like this. Okay, equals to 0. Okay, so VO will be 4 plus 10ki, 4 plus 10ki we know minus V in plus 4 upon 20k. Sorry, this will be minus VO. Minus VO is equals to 4 plus 10k, and we have put in this value, so we will get as minus VO is equals to 4 minus 10 ones are 10 twos are, okay, so we will get minus V in by 2 minus 4 by 2 is nothing but minus 2, okay, so we will get minus VO 4 minus 2 is equals to 2 minus V in by 2, okay, and the minimum value of V in is nothing but minus 10, okay, since you know this is a sinusoidal waveform, okay, so it will be minus VO is equals to 2 minus minimum value is minus 10, okay, so minus 10 by 2 it will be plus 5, okay, so we get as VO is equals to minus 2 plus 5, it is nothing but minus 7, okay, so you can see minus minus will be plus 5, 2 plus 5 7, so VO is equals to minus 7 volt. So this is the minimum output voltage and the maximum output voltage is 4 volt, okay, so the correct option will be this D1, okay.
So till now we have seen the sum where we were not having this load resistance. We have seen the sum where we were having the resistance in one of the branch. Now we are going to increase the level of sum. So this is a 4-star sum, and the sum is assuming diode's forward voltage as 0.7 volt. Otherwise ideal, the output voltage VO of the circuit will be. And this is the sum from EE 2008. This is the circuit and this is the output waveform that we have to find out, okay. So you can see this sum is having the load resistance, okay, so we have to take care of this right now, okay. So we will use the same trick here. The trick says first you have to open this diode and you have to find out VP and VN first. So you can see VN will be is equals to 5 volt. We have just open circuited this diode, so VN is 5 volt and VP is equals to VO, okay, and this VO is not equals to VI right now, because you can see if we open this diode there is a current flowing from this path, okay, so this voltage won't be equal to this voltage, okay, so this time this resistance will be in picture, okay. So now let's check for the condition for diode to be on. We know this diode is having the forward voltage of 0.7 volt. So we have to compare with 0.7 volt. So we can say Vp minus Vn should be greater than 0.7 volt. Vp we know it is equals to Vo. Vn is minus 5 should be greater than 0.7 volt. So we can say for on Vo should be greater than 5.7 volt. Okay, now let's find out the relation between VO and VI. So for the condition when this diode is off, you can see the voltage across this resistor is nothing but VO. So we can say VO is nothing but 10k upon 10k plus 10k is nothing but 20k into VI. I'll just use the voltage divider also. We'll get as VO is equals to VI by 2. Okay. So if we replace this value of VO at this condition, we will get VI by 2 is greater than 5.7 volts. So we can say VI should be greater than 11.4 volt for diode to be on. Okay, and the interesting thing, you can see that input voltage is 10 sine omega t. Okay, so it means the maximum voltage can be plus 10 volt. Okay, but we want the required condition as this should be greater than 11.4 volt. Okay, so we can say diode won't be on for this circuit. Okay, so the output voltage will be independent of this branch. Okay, so for output voltage we have to use this condition only. VO is equals to VI by 2. So the maximum value will be when VI is 10 volt, so it will be 10 by 2, which is nothing but plus 5 volt. Minimum value will be when this VI is minus 10, so it is minus 10 by 2, it is nothing but minus 5 volt. Okay, so you can see the figure which is having plus 5 and minus 5 as maximum and minimum value is this A option. Okay, so you can say this A option is the correct one.
So now let's say this sum, this is of EE 2014 and this is a 5-star sum. Okay, this is the toughest sum which has been asked in the GATE exam. Okay, so this question is assuming that diodes to be in ideal condition. For the output to be clipped, the input voltage VI must be outside the range. Okay, so basically we have to figure out the condition at which there won't be no clipping. So you can see this sum is similar to the previous one, just we have an extra branch here. Okay, so we have to first check for the diode to be in on condition or off. Okay, so this is D1, this is D2. For D1, Vp is equals to Vo and Vo is not equals to Vi. Okay, I hope this is clear for you right now. And Vn will be is equals to minus 1 volt. Okay, so this is Vp and Vn for D1. So for on condition of D1, Vp should be greater than Vn, as we are comparing here with 0. Why? Because the diode is ideal. Okay, so Vo should be greater than minus 1 volt for this diode to be on. And similarly for D2, you can see Vp is minus 2 volt and Vn is nothing but Vo. Okay, we know the condition for diode to be on. Vp should be greater than Vn. Vp, we know it is minus 2 greater than Vo. We can write like this also, Vo should be less than minus 2. Okay, so now we get the condition for diode to be on. But the thing is, right now we know in terms of Vo, we want in terms of Vin. Okay, so for that we have to find out the relation between Vin and Vo. And you can see, if you open both of these diodes, we can say Vo is nothing but 10k upon 10k plus 10k, it is nothing but 20 into Vi. Okay, so we can say Vo is nothing but Vi by 2. Okay, so the condition will become Vi by 2 greater than minus 1 volt. So Vi will be greater than minus 2 volt. At this time D1 will be on, and if Vi is less than minus 2 volt, D1 will be off. Similarly here we can say it as Vi by 2. If it is less than minus 2, then D2 will be on. Okay, it is nothing but Vi less than minus 4, D2 will be on. And if it is greater than minus 4, then we can say D2 will be off. Okay, we want the condition where both of this diode is off, right? So when this diode will be off, then only there won't be any effect of clipping, right? So for off, we get the condition this one and this one. Okay, so we can write it as Vi, it is less than minus 2. Okay, so we can write this, and here we have Vi should be greater than minus 4. Okay, so Vi should be greater than minus 4. So this is the range where we won't have any clipping. Okay, so from the option you can see this B option is satisfying. Minus 2 to minus 4, minus 2 volt to minus 4 volt, there won't be clipping. Okay, so you can see, if you apply this trick, you can solve this type of sum very easily, very fast. Okay, so that's it for today. Thank you guys.